First of all, we want to state that the title up here, 2.1, is not correct. That should be 2.2, 2.3. So let's scratch that out. Let's put notes 2.2, 2.3. This is solving one and two step equations. And we already started doing 2.2 yesterday. We're moving on to 2.3 today. Yesterday we learned about the concept that an equation is like a balanced scale. So there's a blank spot right there. I know you might not have the same artistic abilities as me, but go ahead and draw a scale like that, a balance. And let's put the equal sign right between them, because if it is balanced, that means that the weight is equal on both sides. And then let's actually draw something in here. Let's put a 3x plus 1. And let's say that equals, give me a number. 28. Let's say 28. So this is an equation. And this is the way an equation works. You have two sides to an equation. You have the left side of the equal sign. You have the right side of the equal sign. And you can do whatever you want to an equation, right? Like if I wanted to, I could add something to this left side, but then it would be off balance. Unless I add that same exact value to the right side, then it'll stay balanced, right? Or I could like divide the right side, I could divide this side by 2, and it'll become lighter, which means I have to divide this side also by 2 in order to maintain the equality and in order to maintain the balance, right? So an equation, it has two sides, the left side of the equal sign, the right side of the equal sign. And whatever you do to one side, you have to do to the other. Now, we have to remember the goal of solving equations. What's the goal?
To make it equal.
To get the x by itself on one side, right? We want x equals something. We don't want 3x plus 1 equals something. We don't even want 3x equals something. You just want x by itself. And how do you get rid of something? You do the opposite, the inverse operation. So if we were to look at this scale right here, what would be the first thing to do to get the x by itself? What would I do first?
You would do 1 minus 1.
Okay, I would get rid of the 1 by subtracting 1. That's good. So let's actually put a minus 1 right here. Now, if I subtract 1 on the left side, it's going to be off balance. It got lighter. So what do I need to do to the other side? Subtract 1 also to the other side. So let me do that. Okay, so my new equation, and I know it's not working out that great because it's on the picture here, but my new equation will be 3x, the equal sign still in the middle, and on the right side we have 27. 28 take away 1 is 27. So now my final step is to identify what's happening between the 3 and the x. What's happening between the 3 and the x? We're multiplying. So how do we get rid of the multiplication of 3? Divide by 3. So I want to divide by 3. 3 divided by 3 is 1. What I do to one side, I must do to the other to maintain the balance. So in this case, x equals 9. So there's our answer. I do want to mention that right here we have the instructions to solving any equation. All right, not just a one step, not a two step. I'm talking about any crazy looking multi-step equation. These are the instructions. So step 1, and we're not even doing this yet, all right? Step 1, it says simplify both sides of the equation. So each equation has two sides. It has the left side, it has the right side. Now when I say simplify, what do I mean by that? It says right here, simplify means distributive property and combining like terms. So you see, we're not even doing that yet. Like if I say, hey, go ahead and simplify the left side, is there any distributive property right here, 3x plus 1? No. Is there any distributive property over here? No, it's the nice number 28. Is there any combining like terms right here? Could you combine 3x and the number 1? No. So there is nothing to simplify it. Guys, this is what we call a simplified equation. All right? So step 1 is to simplify each side, but we already have simplified equations on this section. Next week, we're going to get more challenging equations that you have to make it simple first before trying to get x by itself. But right now, all of the equations are simple. But anyway, if you did have to simplify, your next step would be to isolate the variable, the goal, to get x by itself on one side. And remember, what you do to one side, you must do to the other. This second step is what we're practicing right now on sections 2.2 and 2.3. And down here, I have several examples. Let's all take a look at this equation and let's solve it. What would I do to solve it? X plus 3 equals 11. What do I do to solve it? Subtract 3. Subtract 3. Now, let's say you're not too sure. I wrote the instructions right here for you. I explain it right here. We must get the x by itself. Okay, x is right here. You don't want this plus 3. You don't want the plus 3. You don't want that plus 3. So get rid of it by doing the opposite. What's the opposite of plus 3? Minus 3. And remember, what you do to one side, you must do to the other. So subtract 3 here, subtract 3 there. So what's our answer going to be? X equals 8. Come on, people. Wake up. Now, let's say you wanted to double check your answer. What could you do? You could take that value of 8 and plug it in for x. Why plug it in for x? Because x equals 8. So this x is really 8. What's 8 plus 3? It's 11. See? You double checked it. So I have the written explanation, your thought process. By the way, like let's say on a quiz you mess up on this particular equation. This is what I would like to see as your reflection, your thought process. We must get the x by itself. Okay, here's the x. It's on the left side of the equal sign. You don't want the multiplication of negative 3. You don't want this multiplication of negative 3. So you need to get rid of it by doing the opposite. What's the opposite of multiplying by negative 3? Dividing by negative 3. And of course, what you do to one side, you do to the other side. So what's our answer going to be? X equals negative 4. X equals negative 4. So we should all be showing this work right here on the left side on the box. And on the right side, you have the written explanation just in case you kind of lose track of what you're supposed to be doing. Okay, so let's look at this next one. The next one is a two-step equation. The previous have been one step. Now, again, it says right here, you want to get x by itself. X is clearly on the left side of the equal sign. You want to get rid of the minus 5 and the multiplication of negative 2 in the front. So you need to get rid of the loner, right? The bum at the corner first. This is a movie star. This is a movie star's buddy. This guy's a bum at the corner. Let's get rid of that guy first. How do I get rid of a minus 5?
Plus 5.
Plus 5. And what you do to one side, you must do to the other to maintain the balance. So let me rewrite my equation here. I have a negative 2x left over on the left side of the equal sign. On the right side, I have 18. Again, an equation always has two sides. It's the left side of the equal sign and the right side of the equal sign. So we almost have x by itself. What do I need to do next?
All right, divide.
Divide, right? There's really multiplication between the negative 2 and the x. So that says negative 2 times x. So if you want to get rid of that multiplication of negative 2, you're going to divide by that same exact value, negative 2. And when you do to one side, you do to the other side. So that cancels, and you get x equals negative 9. Thank you very much. X equals negative 9. Now, so on this one, we have a fraction. And whenever you want to get rid of a fraction, all you have to do is multiply everything by the denominator. Okay, so what's the denominator of the fraction here? 5. So we're going to multiply by 5, multiply by 5, right? That way we'll get rid of the fraction because 5 on top and 5 on the bottom, 5 over 5 is 1. It cancels out, right? Think of it this way. The 2/5 really says 2 divided by 5. If you don't want the divided by 5, what are you going to do? You're going to do the opposite of dividing by 5, which is multiplying by 5. Cancels out. What do we have left? We have 2x. The equal sign comes down. And on the right side, negative 4 times 5 is negative 20. So we got rid of a fraction. Now we have the regular 2x, which means 2 times x. And if I wanted to get rid of the multiplication of 2, I'd have to divide by 2. So let me divide by 2 here, divide by 2 there, and I'll get x equals negative 10. I think it's important to mention right here, guys, that on this, there's many different ways of doing it. Let me show you. If I rewrite this question, 2x or 2/5 x equals negative 4. Now, over here on this work, I multiplied by 5 to get rid of the 5. You could do that. If you wanted to do the quickest way possible, you could recognize this fraction which it is a rational number, and it's being multiplied by x, so I could divide by that rational number 2/5. Now, when you divide by a fraction, you're really multiplying by the reciprocal. So check this out. This is just a little shortcut trick. If you don't want to apply it, that's fine. I actually don't do this. I actually like to get rid of the fraction by multiplying everything by the denominator. But you could do this. You could multiply the entire fraction by the reciprocal of that fraction. And of course, what you do to one side, you're going to do to the other side. Multiply by the reciprocal of that fraction. Now, why would I multiply by the reciprocal? Because that will get rid of the 5 on top, canceling with the 5 on the bottom, and it will get rid of the 2 on top with the 2 on the bottom, which means everything cancels out, which means that you now have x all by itself.
What?
And what about the negative 4 times 5 over here? Negative 4 times 5 is negative 20, and then 1 times 2, that's 2, which means x equals negative 10. This is a slightly faster way, slightly. But if it gets you confused, then don't do it, right? And like I said, to be completely honest with you, I prefer to get rid of the fraction by multiplying by the denominator. But this is a completely great way of doing it, and it's even faster because it gets rid of everything at once. Over here, I got rid of the 5, and then I had to get rid of the 2 on this part. But over here, I got rid of the 5 and the 2 at the same time by multiplying both sides by the reciprocal. So I'm just letting you know there's different ways of doing these problems. Let's take a look at this one right here. So let's get x by itself. We're going to get rid of that minus 5 by doing the opposite, plus 5. What you do to one side, you do to the other to maintain the balance. We're going to rewrite the equation. Negative 2/3 x equals, because that canceled out, 6. So we could, at this point, multiply by the reciprocal, or we could get rid of the fraction by multiplying both sides by what? By the denominator 3. Okay? So if you want to get rid of everything at once, you're going to have to multiply by negative 3/2. Or if you just want to get rid of the fraction, like if I wanted to just end up with this, look, watch. If I wanted to just end up with negative 2x, instead of negative 2/3 x. If I wanted to end up with negative 2x, then I could just multiply both sides by 3. But if you want to get rid of everything, you could multiply by the reciprocal. I don't know, what do you guys want to do? Get rid of everything, or just take it a step at a time and get rid of the denominator?
Take a step at a time.
Okay, step at a time. I would have to multiply both sides by what?
3.
By 3. So put a times 3 right here and a times 3 over here. Now the 3 on top and the 3 on the bottom disappear. What's left over? Negative 2x equals 6 times 3, 18. So there's my new equation. What's my final step here? Divide, because it's really multiplication here. So you're going to divide by that same exact value, negative 2. So x equals negative 9. That is your answer for that problem. So yeah, you always get rid of the bum at the corner first. The minus 5 goes by doing a plus 5 plus 5. Now at this point, I could have multiplied by the reciprocal, negative 3/2, and that would get rid of everything. But then I'd have to multiply 6 by negative 3/2, and that might be complicated to some people. But if you understand it and you could do it the faster method, go for it. But I actually like to get rid of the fraction one step at a time by multiplying everything by the denominator. Now, there could be... there could be equations that have many fractions in it. This is actually from our homework here. Okay? So let's take a look at, let's say number 16 here. Number 16. I have a fraction. I don't want the fraction. What could I do? Multiply it, right? Because a fraction is really, this is saying all of this divided by 5. If I don't want this divided by 5, if I want that to disappear, right? If I want that to disappear so it'll just be 3k minus 7, well then yeah, we're going to get rid of that divided by 5 by doing the opposite, which is multiplying by 5. Of course, if you multiply by 5 on the left side, you must multiply by 5 on the right side. So the 5 up on top on the left cancels with the 5 on the bottom. So I truly have 3k minus 7 left over. You bring down the equal sign. And over here, 16 times 5, you could use a calculator. That is 80. So now we have an equation without the fraction, and we just handle it like we always do. Let's get rid of that minus 7 by going plus 7. And what you do to one side, you must do to the other to maintain the balance. And we have 3k left over. We have the equal sign. Now notice, guys, I stay organized. I have the equal sign here. It just comes straight down, right? That's what I would like you to do. Don't start putting your equal sign over here, over there. Let's keep it straight down. Keep all of our work coming down in an organized fashion. 80 plus 7 is 87. And our final step would be to divide by 3. Divide by 3. So we end up with k all by itself on the left side equaling 29. And of course, get a calculator. 87 divided by 3, hit equals, it'll say 29. Now let's take a look at a different one from the homework that has like multiple fractions in it, right? 11. That's a great one. Great one. Okay. So you could get rid of, like, let's say, what looks ugly about this equation? The fractions. All the fractions. So we could, remember, we could do anything we want to an equation as long as we do it to everything, as long as we do it to both sides. So like, Caden, if you wanted to get rid of a fraction, which one would you like to get rid of?
7/8.
A 7/8. If you wanted to get rid of the 7/8, you'd have to multiply everything by what? By the denominator, 8, right? By 8. Now, this is going to work out beautifully because when you have the number 2 and the number 8 and the number 8, go for the bigger value, and 8 would be like the LCD, the lowest common denominator between 2 and 8. So if you multiply everything by 8, watch this. Times 8, times 8, times 8. It really does work out beautifully because if you have an 8 up on top and a 2 on the bottom, what happens? You divide it, right? It's like dividing. 8 divided by 2, what do you get? 4. Or you could think of it as reducing. 8 divided by 2 is 4. 2 divided by 2 is 1. Does that make sense? So the 8 divided by 2 ended up being 4 up on top. So that's why there's a 4 up there. How about this 8 and that 8? What happens there? They actually cancel out. So 8 disappears with 8 because 8 divided by 8 is 1. And this one over here also, 8 divided by 8 also cancels out. It's 1. So Caden, by multiplying all three terms by 8, what happened? All the fractions disappeared. And now what do you have left over? 4y minus 1 equals 7. You get it? 4y, there it is, 4y, minus is right there, 1 is right there, equals right there, 7 right there. So we got rid of, I mean, this was an ugly equation that had 3 fractions in it. We multiplied everything by the LCD, 8, and everything canceled out, and it became a nice, simple, beautiful equation. So I need to get rid of that minus 1. What do? Add it. What you do to one side, you do to the other to maintain the balance. We now have 4y equals 8. Final step. I have a 4 times y equals 8. So I need to do what? Divide by 4. Divide by 4. So y equals 2. That is your final answer, guys. So even that ugly equation was pretty easy because any fraction that you have, you could get rid of it by multiplying everything by the denominator. Now, I guess it would be a good idea to show you, what if I wouldn't have, like Caden, you told me to cancel out the 7/8, right? What if I would have said cancel out the 1/2? It would work out a little differently, a little bit longer, but check it out. So on the homework, we did the best thing that we could, get rid of the 8s. We canceled out by multiplying by 8, and it also canceled out the 2. Now let's say you accidentally said, I want to cancel out the 1/2. How could you make sure that 1/2 disappears? What do? You'd be multiplying by 2, right? By 2, everything by 2. You could get rid of any fraction you want as long as you multiply everything by the denominator of that fraction. So if you chose to get rid of the 1/2, you'd have to multiply by 2. That would cancel out. You'd have a 1y left over. But right here, the 2 up here and the 8, they don't completely cancel out. But it's like having a 2 on top and an 8 on the bottom. You could reduce by 2. So it becomes 2 divided by 2 is 1, 8 divided by 2 is 4, so it becomes 1/4. So you have a minus 1/4. It is way longer and uglier, right? So always go for the bigger value. That's the LCD of all your terms. So over here, I'm still going to work it out though. The 2 up on top divided by 2 is 1. 8 divided by 2 is 4. So you have equals 7/4. Now, we got rid of the 1/2. You still have to get rid of the other fractions that have a denominator of 4. So you'd have to multiply by 4, multiply by 4, multiply by 4. You end up with 4y minus 1 equals what? 7. Now, if you solve this plus 1, you're going to end up with 4y equals 8. And then final step would be to divide by 4, y equals 2. So as you can see, that took a lot longer, but there's many roads to the same place in math, right? You don't have to be doing exactly what your neighbor's doing to get the answer 2. We got the answer 2 over here by multiplying everything by 8, and that was way faster, okay? I hope this helps you out with equations that have fractions in it. You could get rid of any fraction by multiplying everything by the denominator of that fraction.